I am Anuradha Bharadwaj, presenting today on the topic Artificial Intelligence is Driving Us into the Future of Genome Editing, Analyzing Big Biological Data. I'm not going to start my presentation with what is AI, because by the time you have reached my presentation, you all must be clear with this funda. We also know that we all are touched with this technology directly or indirectly. But there are very interesting and unusual applications of AI like Brain FM, Receptivity AI, and Path AI. Path AI is rather Path AI. Now, Brain FM, well, it's a team of well-trained professionals of artificial intelligence who are producing specialized music for focus, relaxation, and sleep, written and performed by artificial intelligence. Each note and sound is designed to stimulate the brain accordingly. And it's a really good application of artificial intelligence in the music industry. Next is Receptivity AI, which allows you to analyze the psychology, personality, and decision-making style of an individual by inputting a block of text such as email or a blog and even your Twitter handle. It also feedbacks the best way you can communicate with that person. So in the field of psychology, Receptivity AI is a key player. Next, coming in the biology area, Path AI. Path comes from pathology and AI stands for artificial intelligence. Is a fantastic example of AI in improving diagnostic pathology. It's a Boston-based company which creates AI-powered technology for pathologists and helps them to analyze the tissue samples which make more accurate diagnosis. The aim is not only to improve the diagnosis, but also the treatment. This technology can identify clinical trial participants too. Coming to the next slide, there is a graphical representation of time, yani ki from years back, few years back to the last year 2019, and on the y-axis you can see the cost. So this graph shows that with time, there is a decline in the cost of sequencing. This is how advancement in technology has reduced the cost of sequencing from billions of dollars to few hundreds of dollars. Also, Human Genome Project took 12 years to complete, but now time of sequencing has been significantly reduced to a few weeks. This gives an exponential kick to the high throughput sequence data, providing immense opportunities to researchers to provide disease detection, therapeutics, diagnostics. Now comes the question, why artificial intelligence? It is very difficult to handle huge biological data, the big biological data for the scientist, and here comes the role of artificial intelligence. Artificial intelligence is fair. F stands for fast, A for accurate, R for reliable, and E for efficient. So, artificial intelligence being fair gives opportunity to the scientists, to the researchers to analyze the clinical data, the genomic information very quickly and accurately. How AI in biology? This slide shows some of the areas of genomics and related fields like genomics in precision medicine, genome editing, and drug discovery, where AI is being used and has resulted in wonderful results that could not be possible only by the human hands. If we talk about AI in genome data analysis, so analyzing the genomics imagery data is only possible if we have computer vision techniques combined with deep learning, or more precisely neural networks. Whereas on the other hand, analyzing the genomics text data is possible using deep learning techniques and natural language processing. Deep Variant is an excellent example of AI-based, deep learning-based tool of Google, which employs this technology to transform high throughput sequencing data. The results are reliable and accurate, producing a good picture of genome by distinguishing small mutations from the random errors. The diagram on the right side shows how it works to depict a clear picture of the genome. Genelia's, DNA Access, and AI therapeutics are the budding startup in this field. When it comes to artificial intelligence and genome editing, CRISPR-ML of Microsoft is the key player, which has prepared a wonderful model by training its model with enough data sets for improved efficiency and efficacy of the tool. In Delphi, Forecast, and Sprout are other artificial intelligence based companies which work in this field. The idea is not only to improve the efficiency and decrease the off targets, but also to enhance health with diagnostics and treatment on the basis of FAIR rule, FARE, which I discussed. Keeping in mind the major focus of my presentation, which is AI in big biological data, how AI is helping us to fight this pandemic. Although there are n numbers of solutions AI has provided, but I'm particularly focusing on the big biological database solutions. So number one is in detecting corona and forecasting its outbreaks, to diagnose the virus, to give good results on the basis of literature mining and literature analyzing through AI has led to very good discoveries, and genome analysis, protein analysis, and then vaccine designing. For example, if we talk about diagnosing the virus, if we talk about use of artificial intelligence in detecting coronavirus forecast outbreaks, Blue Dot, which is a Canadian startup, is based on AI to detect the corona. It helps in tracking infectious diseases risk with the help of artificial intelligence. When it comes to diagnosis, Alibaba, a Chinese e-commerce giant company, has also provided AI-driven diagnosis system to diagnose the disease. The results are 96% accurate within few seconds. When it comes to literature-based discovery, the Corona-19 Open Research Data Set, which is also called CORD-19, is an initiative building on Seattle's Allen Institute of AI. And the project is Semantic Scholar Project. It uses natural language processing to analyze tens of thousands of scientific research papers at an unprecedented pace. Coming to the most important, genome, protein analysis, and finally producing vaccine. So at the University of Washington Institute of Protein Design mapped 3D atomic scale models of the SARS-CoV-2 spike protein that is mirrored or exactly same to that discovered by University of Texas Austin lab. The team is now working to create new proteins to neutralize the coronavirus, and the protein would have to bind the spike protein to prevent healthy cells from being infected. Though we were not ready this time with full potential of artificial intelligence, but yes, in future, artificial intelligence and us are ready to curb the next pandemic. Thank you.